Alright guys, so we are done with the A part of the question. So if you haven't watched how we got the Venn diagram for the A part, you can watch my video on logical reasoning 1A to help you understand it better. So now let's look at the B part. So the B part, we are required to determine which of the following statements are valid or not valid conclusion from P. Okay, so the first one is John is a policeman, so he wears uniform. John is a policeman, so he wears uniform. So let's determine whether it is valid or not. So let's come to the Venn diagram. So if John is a policeman, then it means John will be inside the set A, right? John will be inside the set A. The set A represents the set of policemen. Okay, so if John is inside set A, then automatically he is also inside set B, which is uniform men. So we can see that the first statement, which states that John is a policeman, so he wears uniform, is always true, because once John is here, then it means he's also inside the set B, right? Once he is a policeman, then of course he's part of the uniform men. Very good. So you can say that the statement is always true. Always true. Hence, it is valid. Very good. So for the statement to be valid, then it means it must always be true. If it is not always true, then we cannot say it is valid. Very good. So let's move on to the second one. Okay, so the II states that Hamza wears uniform, so he is a policeman. Hamza wears uniform, so he is a policeman. So let's see whether this statement is always true. So let's come back to our Venn diagram. So if Hamza wears uniform, then it means Hamza is inside the set B, right? So Hamza will be here. So meaning Hamza can be here. He can also be here, because this region and this region are both in the set B, those who wear uniform. I hope you can follow what I'm saying. Okay, so here it could happen that Hamza can be, once Hamza is wearing uniform, it could happen that he can be a policeman, which is that he can be found in set A, or he can also be found in this region, which is outside set A, but it is inside set B. So this region represents those who wear uniform but are not policemen. So you can have, let's say, nurses or students or soldiers, right? Okay, so what it means that we cannot conclusively say that once Hamza is wearing uniform, he should be a policeman, because it's either he's not a policeman or he's a policeman, right? As it can be seen from the Venn diagram. So we can say that that part of the statement is not always true. So the II, you can see that the statement is not always true. Always true, because if he's in uniform, he can be either a policeman or he can be a different person, right? Very good. So it is not always true. Hence, once it is not always true, it means the conclusion which states that once he is wearing uniform, so he is a policeman, is not valid. So hence the conclusion is not valid. So this is not a valid statement or conclusion. Okay, so now the third item, which states that Benedicta does not wear uniform, therefore she is not a police woman. Benedicta does not wear uniform, therefore she is not a police woman. So let's come back to our Venn diagram. So if Benedicta does not wear uniform, then it means Benedicta will be in this region, right? So it will be outside the region B. So this is the region B. So since Benedicta does not wear uniform, it means she will be outside this region, but inside the rectangular box, right? This portion. So these people are those who does not wear uniform. Okay, so she will be here, and the statement says that Benedicta does not wear uniform, so therefore she is not a student. So since she is here without uniform, there is no way she can be found in region A to become a police woman, right? So we can say that this statement is always true, because once she's not in uniform, automatically she can't be a police woman. She can be a different person, right? Very good. So we can say that the statement is always true, because once Benedicta is not in uniform, then automatically she is not a police woman. So the statement is always true. So once the statement is always true, then we can say that the conclusion is valid. So we are done. Hula! So like the page and share it to your other colleagues. See you in our next video. Thank you.